later today, I will be taking attendance. So if you want to leave, make sure you tell me before. Now, one more time, rate of growth or rate of change in anything, it's always the end point minus the start point over the start point. For example, some variable x, your end point is x2 minus your start point over your start point. This shows how much we moved from our start point relative to our start point, how much we moved forward. Now, in economic variables, the rate of change is often called growth. For example, growth of output. It's always our output now minus our output before when we started over our output before, which is delta y over y. This is your rate of growth. Growth rate of output. And it also exists for other variables, technology, capital, and labor. Now, if you want to write down the growth rate of output in terms of growth rate of other variables which are input in our production function. Remember the Cobb-Douglas for the production function, you got A, K, and L. That's the Cobb-Douglas. In the Cobb-Douglas production function, you can write your growth rate of output as your growth rate of total factor productivity plus alpha, growth rate of capital, plus beta, growth rate of labor. This alpha is the power. This was our production function. You can prove this, but it's too long and annoying. I mean, to get to this final formula, final equation, you don't need to like show it on the exam. I won't ask you to prove this to me, for me on the exam, because it's just time. You have to like cancel this, cancel out. And remember, this is very important. Alpha plus beta is always equal to 1. So they are always smaller or equal to 1, both alpha and beta. And alpha plus beta always equals 1. Now, we can use this equation and the fact that alpha plus beta is equal to 1 to prove the two characteristics of a production function: diminishing marginal product and constant retentive scale. Diminishing marginal product, you can see that, for example, if your alpha equal 0.3 and your beta is equal 0.7, if your capital grows by 5% and your labor remains constant, what happens? If this is 0, your labor remains constant. This will be also 0. Your technology will remain constant. And if this grows by 5%, and this is equal to 0.3, your total growth in output will be equal to 0.3 multiplied by 0.15, excuse me, 0.05. This is 5%. So the final result would be 0.15, which is lower than 0.5. Must be 0 here. Yeah. Same for labor. If your labor grows by 5%, then output will grow by 0.7 multiplied by 5%, which is 3.5%, less than 5% growth in labor. This demonstrates diminishing marginal product. So if you hold the other variables constant and you grow your labor by a certain amount, your total output will grow less. There is another characteristic, constant returns to scale. If both of them grow by 5%, let's assume both labor and capital grow by 5%. This will remain constant, so this will be equal to 0. Let's say both of them would grow by 5%. Now, again, this will be 0, so you get rid of it. You can factor out the 5%. Now, tell me, what is this?
1.
Exactly 1. So your total output will grow by 5%. This is the other characteristic of a Cobb-Douglas production function. One more time, you factor the 5%, alpha plus 1, alpha plus beta equals 1, therefore you end up with the same number. This is very important. Make sure you know this for your exam.
Wait, so you're saying if they both grow at 5%, then it does increase by 5%?
Yes. If both of them, if your labor and your capital grows by 5%. Let's assume this. If you have a, let's say you have a car repair shop. Let's say you're a mechanic. You have a car repair shop. You have one mechanic and one toolbox. How many customers can you satisfy every day? Let's say 1. Now, if you hire one more mechanic equally as skilled as the first one and give him one toolbox, the same as the one you gave to the first mechanic, then you can satisfy 2 customers per day. One can work on the usual customer car, the other one can meet a new customer. So you can double your output. If you double both your capital and your labor, and your technology remains constant, you will double your output. Make sense?
Mm-hmm.
Great. So now we have this productivity growth, capital growth, and labor growth. These are again typos here. Now remember this solo residual or a time t total factor productivity. Gross accounting indicates that different economies often have different reasons for output growth. Of course, now we understand that the more important source of variation, the most important driver of economic growth is actually this. Capital, labor, they're all important, but total factor productivity is the most important. The accumulation of knowledge, skills, experience, efficiency. Total factor productivity is not only technology, it's all these other benefits that a good working, like a responsible government and a good society brings. When everything works in order, when there is no corruption, when there is a effective law enforcement, effective legal institutions, good government, sound policy making, good schools, effective research centers, all of that put together, total factor productivity. Now, up to this point, we worked with the Solow model. Solow model, remember, it tries to explain economic growth in the 1950s. Japan and Germany, the two countries that were destroyed because of the saving rate, because of the because their capital, physical capital was gone, and they were saving a lot. They were growing faster than the United States and Great Britain, France, and all the other countries like that. Because their saving rate was was higher, they managed to grow faster and catch up. But Solow model can't explain why other countries, for example, in Africa or in some parts of Asia, couldn't catch up. What was the difference between Germany and some countries which couldn't catch up? The difference is total factor productivity. For that, we need the new model, which is chapter 7. Okay, great. So this is chapter 6. Now, before I start chapter 7, let me quickly take it. Attendance.